and share my screen. Okay, and now we should be in a good spot. Okay, perfect. Okay, so here we go, guys. For this next couple of topics, we're going to be next couple of lessons. We're going to be using some PowerPoint slides. Okay, to go through things here. Whoops. So the idea here is to get some different ways of taking notes. So I try to mix it up a little bit so you guys have different varieties here. So you prepare for high school because different teachers use different approaches. Okay. So you notice sometimes I have this I've written out for you on the ability. You just take those down. Okay. Other times I have handouts for you already typed out. You just add to those. Okay. Now you're going to do this from a PowerPoint presentation. Okay. So why don't you copy this system down in your notes. Okay. And I'm going to give you some direction, and you're going to work in your groups for a couple of minutes. All right, on what we're going to do here. Okay. I want to iterate from the very beginning here. We're not looking for right or wrong answers. We are just experimenting. Okay. We're just going off of instinct. Okay. And just what we think we're supposed to do. I'm not going to tell you if it's right or wrong right away. Okay. You guys are going to try some things. We're going to discuss it. And then I promise you, before this is all said and done, you will know the right way to do things. Okay? I promise. We're going to get there first. Okay? Are you ready? So on Friday, I believe I told you there were 3 methods to solve a system I'm going to show you in this class. Okay? On Friday, we finished the graphing method. That's where you graph your equations, you figure out where they intersect, right? Okay, good. So today, we're going to start on the next method. It's called the substitution method. All right? So just by knowing that we're going to call this method the substitution method, all right, and just knowing that information alone, I want you to try to solve this system, okay, by substituting something. All right? So when you're done, I want one value for x, and I want one value for y. Okay? That's your task. So you're going to work on it in your groups together. So if you have 4 or 3 minds working on it together, okay? So I want to hear some good dialogue as I walk by. And then at the end of the dialogue, we'll talk, we'll meet up what you guys discussed with, and we'll go from there and we'll start getting it fine-tuned to the right approach, okay? Right now, just experimenting and thinking about what substitution might mean in this case. Okay? Go.
I feel like you might point something.
Yeah, maybe it's like something, I don't know, maybe it's like you.
No, let's not. Okay? No guess and check, guys. Okay, that's not the same thing as substitution at this point. Just FYI. Miller House tried to get away with that yesterday. I quickly put a stop to that. Okay?
Oh, I already know what it is. What? I figured it out. Yeah, so you can plug it into that end. Because look at the first one. I was like, wait a minute. I'm mad at you.
Okay, I can't wait any longer. I have to know what you guys talk about. You want to share out what they discussed in the groups as a possible approach to solving the system here? No. Just joking. Okay. All right. We got some people that are willing to take the risk here. Good. And what did you guys discuss?
Well, the first thing I thought was substituting y and x for like a point like we did and like what was the method? One of the forms of writing like a slip form.
Oh, like okay. Okay.
Um,
Like for standard form. Okay.
so like you're writing a plot, but the only thing I could think of that like we could get from the equations was the y-intercept.
Okay.
It happened to be the same in this equation,
Uh-huh.
but
Okay.
that's not gonna be a constant depth difference.
Right.
So,
Okay. All right. Well, that's a good thing. That's a good starting place. Okay. That's good. Anybody else have something else to try? Don't be afraid to speak up. Okay. Again, we're just going through possibilities here. Okay. Everything's on the table. All right. Somebody yesterday actually had the right idea, and was afraid to say it, and then realized that Robin had the right idea. So it could be you too. Okay. So just saying. Eliza, what do you think?
I don't know. I thought it might have something to do with like subtracting the y-intercepts or something like that, and seeing how far away from them it would be or something.
Okay. All right. Okay. Anybody else? Caitlin? Okay. Now remember, your x and y have to satisfy both equations at the same time for it to solve the system. Okay. So your value for x has to make both equation 1 true and equation 2 true. Likewise for y. Okay. So did that work for you this time? Not sure. Okay, that's fine. Would it work every time? Would 0 be the solution every single time? Yeah, also, that's the whole thing we got to consider here. Okay. We get this figured out. So I think we're starting to get there a little bit. Yeah, that's good. All right. You guys, remember doing like these function problems when we did them before, like when we said, or maybe in earlier grade, you said if you had like if x equals 3, find 4x minus 1. You ever seen a problem like that?
oh, yeah.
What did you have to do when you solved this problem? Raise your hand and tell me the approach. What did you have to do, Wyatt?
You would plug in x and then solve. You would plug in 3 for x and then solve the problem.
Okay. So you're used to being able to substitute. Wouldn't that be a form of substitution? Oh,
The guess and check method was right.
okay. So this would be, okay. But does this have to equal a number? No, it doesn't. What if I said this? What if x equaled 2x plus 5, or 2y plus 5 for that matter? Let's just say that, 2y plus 5. Did I still plug it in for x? What would the answer be? Can you figure that out real fast? Emily?
2y plus 5
Mm-hmm. Yeah. So it becomes 8y plus 19, maybe? 8y plus 19? Did I get that right in my head? Okay. All right. So again, we took something for a variable, replaced it in the expression, and got a new expression. All right? Do I have an equation solved for a variable already in my system? Yeah. Which equation is already solved for x or y, kids? 1. Okay? How can that help me get an equation all in one variable? If I get an equation all in one variable, I can solve for that variable's value, right? How can I get that? How can I take this, how can I use this equation here to get an equation all for one variable, x or y? And solve that equation. Anybody think about this? Anybody come up with something? About 90 seconds, how about a quick discussion with the group mates if you guys come up with something, okay, on this, okay? So the question now at hand, can you use equation 1 equation. All right, that's what we're looking at now. Okay, discuss.
I said maybe you could substitute that, so you could use the substitute, put it in, probably have it was, probably not my version, and then solve it.
Oh, is that possible?
So you like,
You know what? You could be more right than you know, Eliza.
Yeah, it could be.
At some point in time.
Doing
You could
so.
follow some sort of like your pitfall of the processing it to parallel.
Guess and check this out. Sorry.
Guess what check is going to be?
But here's the problem with that. You might be guessing and checking for a long time. Okay, we gotta be more efficient. Okay. All right. Any thoughts on how that might in play? Can I come play here with this? Okay. Go back to our example over here on the board. I substitute an expression into my variable, right? And now I have a new expression. Okay. Then I do the same thing over here. Emily?
so you play, I think, you can take 5x minus 2 and equal 5, and plug it in for y in the second equation, and then solve x.
So what Emily is saying here is that you could perhaps, we're not verifying this just yet. Okay? You take your 5x minus 2 expression here, replace y with that, and you have an equation all for x. Okay? Because y equals this expression, I can swap them out. Okay? Why? What are you thinking?
I was thinking the exact same.
You're saying the exact same thing. Okay? And ladies and gentlemen, as it turns out, in order to substitute in a substitution system, that's exactly what we do. Okay? We take an expression, solve for a variable, and we substitute that expression for the variable in the other equation. Okay? So, since equation 1 is solved for y, okay, we're going to take that expression on the right, an equal sign, okay, and we're going to change y to that expression in equation 2. By doing so, I'll have an equation all with the variable x. I can solve that equation, get the value for x, and then I can figure out how to get the value for y. That's the substitution method. Okay? Now, that sounds really tricky, right? I'm going to help you out a little bit with this. I got a couple of tips you can use to help you keep things organized here a little bit. All right? So follow me here on the next screen, and I'll show you what I mean. All right? All right, so here's what we're going to do. Step 1, okay? Draw a box around the expression that we replace y in equation 2, okay? Y equals what in equation 1? 5x minus 2. So then draw a box around 5x minus 2 because that's what you're going to change y to in the second equation. Does that sound good? Okay. All right, now here's what I like to do also. Help me out even more. I like to draw an arrow from the box to the variable I'm substituting for in the other equation. Okay? So I'm going to draw an arrow to the y. So I know that when I rewrite equation 2 to change the y, I change that variable and not mistakenly the x variable. Okay? So here's the deal. Okay? I'm now going to change this right here to 5x minus 2. Okay? I'm going to show you what it looks like. Are you ready? So this is what I have so far. And now, this is what the new equation 2 looks like, all right? I'm going to show it to you, then I'll explain what I have up here. This is what I have. Does this make sense? This was for the y was. Now I'm changing it out for what's in the box. Okay? The 6 stays where it is, all right? So in order to keep everything intact, I have to put this around parentheses because it's 6 times y, right? So it has to be 6 times whatever I change y to. Okay? Maintain the value of the equation. Are we good? Okay, now I have an equation all for x. Negative 3x plus 6 times the quantity, 5x minus 2 equals negative 12, and I can solve that and get a value for x. Okay? That's the substitution method, all right, in a nutshell. You take a value for it, you solve an equation for a variable, you take that value of the variable, you replace it in the other equation, you solve that equation, and take that value, and we'll get the other value with it, all right? In a nutshell, that's what we have to do here. All right, so, and again, in order to use parentheses to enclose the expression in the equation, okay? So, I want you to help me solve this, okay? Here we go. There's the equation. Oh, there it goes. Okay, good. Now, what's the first thing I have to do to solve it? Help me out here. Sadie?
Solve the parentheses.
So I have to distribute what?
6 to 5x.
So negative 3x plus what? 6 times 30x, good. And then 6 times negative 2 is? And that equals negative 12. Everybody okay with that? Go ahead and start solving it now with me, okay? Combine your like terms. Negative 3 plus 30 is 27x minus 12 equals negative 12. Okay? It'll catch up. It's slow. All right. Next step. Add 12 to each side. Very good. Those cancel. You get 27x equals 0. Okay? Divide both numbers by 27. What's x? X is 0. Yep. There it is. Okay? So we have one of them. We got x now. Now I got to find what y is. Okay? Suggestions on how that happens. Okay? Talk to your group mates about this. All right. So, thoughts on how to get y now that we know x is 0? Okay. Anybody have any ideas on this? Again, nothing's off the table. Blake, what do you think?
What if you plug in the first equation to the x?
So what you're saying is, in the first equation, let x be 0, solve for y?
Wait.
Are we saying the same thing?
No, I was saying like plug in 5x minus 2 to. What I was saying was you plug in. So basically, you would reverse it instead of plugging that in for y, you would plug it in for x.
Okay, well, the only problem with that is that y equals this expression, not x. Okay? And we know, though, that x equals 0. That's a big help now. All right? So what do we think we need to do here now? Why? What do you think?
Well, if we just plug 0 in for x and then solve the equation.
Yeah. Pick an equation. X is 0. Replace it. Solve for y. That's it. Okay? Does it matter which equation you select? No, it doesn't. Okay? Because remember, the solution has to satisfy both equations. All right? So you put 0 in either one of them. Plug it in everywhere there's an x. Okay? And solve for y. But is there one that might be easier in this case to use? Show me on your fingers, 1 or 2. Okay? Why 1, Toby?
Because it's smaller
And it's already solved for
y.
That's exactly right. All 3 of those reasons. Okay? All right. So, for that very reason, I'm going to use equation 1 up here on the screen. Okay? You don't have to use equation 1, but that's what I'm going to do. All right? So, there's the original equation 1. X is what value? 0, right? What is 5 times 0? So I get y equals 0 minus 2. And what's 0 minus 2? So x equals 0 and y equals negative 2. And I'm sorry that this is getting kind of choppy. It's because I'm recording it. Okay? And I'm screencasting to my computer. But that's exactly what it is. Ladies and gentlemen, you just solved your first system by substitution. Okay? Let me recap what we just did. Okay? You will solve one of the equations for a variable if it's not solved for already. Take that expression for the variable, replace that variable in the other equation with that expression. Solve that expression. Solve that equation. Okay? Then, like we just did here, take your value that you find, pick an equation, replace it, solve for the other value. Okay? And you get your order pair. Okay? You can write this as the order pair is 0, -2, if you want to. Or you could say x equals 0 and y equals -2. I take anything on this answer. Okay? Are we good? Show me a thumb. All right, so here's what we're going to do. I'm going to show you another one of these. I'll try to get through at least one more today with you. Okay? And then we'll start making this a little more interesting probably on Thursday. Okay? Let's move on. So, here's the next one. Okay? So, in your groups, now have a discussion. What are you going to replace? Which are you going to substitute for? And in what equation are you going to substitute it in? Okay? After you get it down. I'll give you a chance to get it down so everybody's on fair start here. What equation are you going to substitute in and for what variable? Okay, that's what we're going to discuss now. Okay? 30-second discussion in your groups. Go. I'm rolling the dice. Do you want the easiest?
Does anyone know
Yeah, because if you press the, it simplifies the. Yeah, so the number 2 and 1.
it's already set for x, so we just plug it into x.
All right. So like we're all done conversing. Brandon, what did your group decide? Do you need more time to talk? Okay, you take 10 seconds to talk. Okay, I'm gonna go back and roll the dice again. I'm gonna get Brandon on something else later on. Okay. All right. So I know I might pull Brandon again. You never know. Okay. All right. I did pull Brandon again. I rolled Reed's number and he's gone. Okay. Now I roll somebody else's number. Okay. Tony, what would you do? Okay, so what you're saying is you would take, I think I got the Justin. I'm guessing you're trying to say you're going to take this expression for x in equation 2, plug it in for x in equation 1. Is that what you're trying to say? Yeah, okay. That's what I would do too. Is that what you have to do? No. Okay, is it the easiest thing to do in this case?
Probably.
Absolutely. Okay. On Thursday, we're going to tackle some of these where you don't already have an equation solved for a variable. Okay? And that's going to be one of the most difficult problems of this type that I can give you. All right? We'll worry about how to get there so you're in this situation on Thursday. Okay? It's not that difficult to get there. You know how to make the equation. Okay? So you just manipulate it to get the form you need. All right? So, I agree. We're going to take the value for x in equation 2, replace it with x in equation 1. Everybody okay with that? Let's go. Okay, let's go. So, draw a box around the equation in x, or the expression for x in equation 2. Draw an arrow to x in equation 1. Okay. Then when you rewrite equation 1, again, change x. Okay. What does x change to? What do you replace x with? Sadie?
2y plus
Bingo. Okay? So it's going to look just like this. Oh, that's much better. Okay. Solve for y, guys. solve for y, and then I'm going to have you guys discuss the answer to group means. Don't worry about x right now, just solve for y, okay? We'll take care of x together in just a minute. Just solving for y at this point. You guys are allowed to use your calculators if you need. I will tell you that for our purposes right now, the answer will not be a fraction.
Do you want us to put it in the decimal?
No, it's not going to be a decimal or fraction. It's going to be an integer. Okay? I'll tell you right now, the answer that we need right now is going to be an integer. Remember, Eliza, that it's a plus of minus. Copy it down. It changes some things. All right, discuss with your group mates, guys, if you're ready to go. Okay, who wants to volunteer their answer? Oh, good. Caitlin? All those in favor of -4? So am I. Okay? I get y equals -4 also. Okay? Everybody see how this is going to work out? Now, you have y equals -4. What do we have to do now? What? We got to plug it in one of the other, in either equation, it doesn't matter which one, okay? And solve for what? Oh, so what we still need to find, kids? X, okay? Okay, so you can pick either 1 or 2, doesn't matter, okay? Plug in x equals -4, solve for y, okay? No, y equals -4, right? I'm sorry. So plug in y equals -4 and solve for x. My mistake. Okay? I'm going to select equation 2. Just because. Okay? There's the equation. There's the substitution. What's 2 times -4? I get -8 plus 11. What's that become? 3. So therefore, x is 3 and y is -4. There it is. Okay. Substitution method. What do you think? Kind of iffy? Okay. Let's go away on Thursday to practice some more then, okay? That's what we're going to do. And if we need Friday to finish up a little bit, because you guys are going to have, well, Thursday's going to be a regular period for us. So you'll be able to finish it all up on Thursday, okay? And then next Tuesday, we'll start the final method that I want to show you on this stuff. All right? We got just a couple minutes left here. I'm going to show you the next problem. Once you get a start on it, we probably won't get it done today, but at least we'll get it started. We'll finish it when we come back on Thursday, okay? Nice work, everybody. Okay, try this one on your own. Caitlin, what's up? All right, so that one. Okay, so now we go to your app. Go on your app. Okay. Must have missed it.
Yeah, you don't want to grab.
Oh, there it is. Oh, hang on. Okay. Got it. Okay. It's going to install on your iPad. When it does, let me know. And we'll talk about how to get it in, okay? It's real simple. Okay. If you guys finish this up real quickly, guys, for today, you guys can call it quits today if you want to. A couple of things. On your assessment for this topic, okay, I will specify for some of the problems you have to use a certain method. Okay? Like I will say, solve this system by graphing, or solve this system by substitution. Okay? If you don't use that method, even though you might get the right answer, I cannot give you full credit for the problem. Well, you can, but it's not necessary. Okay? So if you have a substitution problem that's been stated, solve a substitution, and you do it a different way, the most I can give you is 2 points out of 4. Okay? 1 point for each answer in the system. Okay? In the solution. All right, we're going to cut it. We're going to stop it there. And I'm going to come around and start sanitizing your desks. Okay? Nice work today, everybody. You guys were at a little bit of a disadvantage from yesterday because I gave them a little bit of heads up on their fire up on what to do. So you guys really did a really good job today.